to make an animation, we're gonna need a new class and that PNG file. So let's start by adding that one. I think I'm gonna rename this to be capital letters instead. More beautiful. We're gonna have to change a little bit in the code when we do this. Okay. Texture, add existing item. In my art folder, I have the computer sheet, so I'll move it over to the project folder instead. All three of these should be copied to the output directory. Doesn't matter if it's a debug directory or release directory. And we of course need to note the name of the asset. The name of the assets of the other two changed because I capitalized them. And now we have an image to play with. So let's go to graphics, add a class, and then we add an animation class so we can try out our calculate source method. I don't think we need the properties anymore, probably not the solution explorer either. Okay. Now this class will inherit from image. If you're still shaky on the vocabulary, I suggest you view video number 6, I think it was, again, so that you have an easier time following along here. Okay, we're not going to use these, but we're going to keep that one, because that's where the list is. It is part of the .NET framework, and we're not going to type the fully qualified name. We're just going to use a using statement. We're also going to have Microsoft XNA, of course. And we're going to use the graphics part of XNA as well. Okay. We're going to need some fields. Specifically, we're going to have the list of frames that we're going to use. We're going to have a boolean to check if the animation is looped. We're going to have a started. We're going to have something to check if the animation is started or if it is paused. We should have the current frame as well. That's just going to be a float. We'll talk more about that later. And we should also have a speed. So let's do frames per second. I'll end this region as well. The first one was the list, and this one takes a type parameter, and since these are going to be passed to source, they should be the same as source over in the image class, and they were rectangles. So I'll define this as rectangles, and we'll name it frames. We're also going to have a boolean. I can't type today. Is started, and a float, which is current frame, and we're gonna have a float which is frames per second. Okay. Frames per second should probably not be lower than 24 if it's a smooth animation that you want, but we can set it to lower than that if it is something that is okay, that is choppy, such as our computer screen that we will animate. I'm going to put in a property right away too. Because I want to be able to start and stop. So we're gonna get a public boolean which is started, and this one is going to get the is started variable, and we're gonna have to be able to set it as well. And that's it. Okay. I don't think we're gonna need to look at this right now, so I'm just gonna collapse them, and then we move on to the main methods, because that's where most of the work is going to be done. We are gonna do 3 of them. We're gonna do the constructor, because we need to get a list class into that list field that we had, the frames one. We're gonna need to initialize, which is when we will fill frames with different kinds of rectangles. And we're gonna, during the update method, switch to different rectangles to make an animation. Okay. Here we're gonna put in a constructor. So I'll click tab, and this one will take this object's frame field and pack up a new list of the rectangle method. I'll just use IntelliSense for that. Where did IntelliSense go? Oh, there it is. That should be fine. And then we move on to the more important initialize method. Now this one will illustrate some of the inheritance concepts. We're gonna make this one public, and then we're gonna override the initialize method that is in the image class. So I'll type override void. Can you see that it's not in the list of different methods that are accessible? Well, that's because image doesn't allow it to be overridden. So if we go back here to the initialize method, we need to make this one virtual. That will allow initialize in the image class to be overridden in the animation class. So when I hit space now, then you have initialize there. So I'll click tab, and then it fills in the rest, calling the base class as well. Most of these methods are very easy to initialize. We have this dot frames per second. That one we can just set to 1. And then we have the current frame, which will start with the first frame of animation. And then we have the is loop. Maybe it should be is looped instead of is loop. I think I'm gonna go back here and change that one. I'll click F2, and I'll add an ED and click OK. Looks fine. Gonna change everywhere for me, in case I typed it more than once. So is looped should probably start out as true, is a good idea. And is started should probably start out as true as well. And on the base class, we also have this size that we would need to set. You remember in image class we had it as the whole uh, texture, and we need to change that. However, again, it doesn't show up in the list. That's because over in the image class, size is in the fields here, it is declared as private. You remember there were three different that were private, protected, and public. Private, then only the class can access. Public, anybody can access, and protected, uh, children or derived classes can access. So if we change this one to be protected, then we will be able to access it. We're also going to need to make origin protected. Because instead of having the center of the texture, we want to have the center of the source instead. Later on, we will also change the value of source, right? So let's make that one protected while we're at it. And then we go back to animation. Now if I click period, then I get it in the list. You have size down there. I'll move it up a bit so you can see more clearly. Size. Now we can access it even though it is a field on the image class because we're inheriting from it. So we'll set size to a new vector 2, which is I think that each computer in that texture I made was 64 pixels wide and 64 high. Yeah, I'm pretty sure of that. So I'll put that in, and then hopefully I'm right. And this origin is available as well. So we'll set that as a new vector, and we'll do half of this object's size, because that one has decreased in size, right? So half of that is 2, and this size, oh sorry, we should have an X there as well, and this size should have a Y, and then we divide that by 2. Now that wasn't so exciting, because the exciting part is then using the calculate source to list all of the different rectangles that we've got. And in the future we will read this from an XML file, but right now we're just gonna pretend to read from an XML file. So I'll do first frame, that's the starting animation. And we're gonna have the last frame is gonna be 9, right? Because the computer sprite sheet had 9 squares. We're gonna use all of them. And now we're gonna use that for construct that we talked about earlier. So I'll type that in and hit tab twice. And we're gonna have an index for each frame, and as long as index is less than or equal than last frame, then we're happy. We're gonna keep executing the code. I'm gonna put in the equal sign there as well. Now the code in here is gonna be executed 9 times. Sorry, that shouldn't be 0, that should be first frame, right? Start with index being first frame. As long as it's less than or equal to last frame, then we're good, and increase it by 1 each time, so 9 times. 9 times we will add to this object, it's outside the screen again, I'll take it up. We'll add to this object's frames. This was a list, so this is a class that already contains some methods. So we'll just use that add one. You see there are many that you could use, but add and remove probably the ones you're gonna use in the beginning. There are a few others too that we might go over later on when we need them, but right now we just need add. So we're gonna add a new rectangle, but we're not gonna type new rectangle because we're gonna let calculate source use it, but it doesn't show up in the list. Why is that? You should know the answer by now. It's over in the image class. We have calculate source, right? And it's private. It shouldn't be private. It should be protected, right? So if we try that again, then we get calculate source. So I'll use that, and we'll pass in the index that we made. I'll close that up, and then we're done with this. I'll show you about what is going on here. The first frame is 1, the last frame is 9. We set index to be 1, and then we use the frames list that we have made to add a new rectangle. So we call calculate source just like before, but before we passed in 0, this time we pass in 1. So we get the first square of the 9 squares that we have on the first frame. Then when we get down here, it gets repeated, but we increase index, and then we pass in 2. And it keeps doing this until index gets too high. Now let's make an update method as well. You might remember that in the image, in the main methods among image, we don't have update, so we don't need to override anything. I'll just do a public void update, and that should be fine. We make a new one. And the design decision we've made before is to pass in game time. There are other ways to do it instead of passing it in. We can talk more about that in maybe in video 26, I think. But for now, we'll just pass it in. Okay, if this object is animated, I'll scroll down so you can see. If this object is animated, as if it is started, which one should we use? Well, this one is for public use by other classes. So if we add some code inside this property, then by calling the property, then we'll be fine. However, calling this one is faster, so it's a bit tricky to pick one. The correct thing to do is probably to use a started, but I'm gonna use this one because it's faster. Not that it needs to be fast, but that's just something I'm used to doing. I don't know if it's the correct thing to do. If this one is animated, then we need to reset the, then we need to update the current frame, right? So this current frame needs to be increased, right? So we'll do the addition assignment operator. We need to add this frames per second times the elapsed time. But the elapsed game time in seconds is a float. Sorry, yeah, what is it? I need to check. Float. Is it that perhaps? Game time, elapsed game time, um, total seconds. What is that? That's a double. Well, that's good. Then we can convert it to a float. So we have a float times a float. That's much better. Now, after we have increased, we can check and see if this is looped, because if it is looped, then this object is looped. Then maybe we increased it too far, so that we are out of bounds of the list. Maybe the index gets to be too high and we're trying to access frame number 15 and we only have 9. So if this is looped, then we need to reset it if it gets too high. And I'm going to use the modulus assignment operator. So this current frame modulus operator, this frames, this one has something inside it that we can use, so I'll show you. Down here you have a count, and you get the total number. So what we're doing is that we are dividing current frame by the actual count, but we are only returning the remainder of that, which we then assign back to current frame. This is a practical way of wrapping something so that it doesn't go too far. You can do it if you have a sprite that goes from the left side goes over to the right. When it gets outside the screen on the right side, then if you use this same formula as this is, you can wrap it around so it goes back to the left and starts going around the screen again. However, if this is not looped, then we still need to check if it is too high, the number, because we multiplied and added here, right? So it might have gone out of bounds anyway. So even if it is not looped, then we're still going to have an if statement. If this current frame is more than what it can be, so we're going to use this frames count again. If current frames is more than what it could possibly be, then we need to reset it. So we have this current frame equals this frames count minus 1, right? Because current frame is a list which is 0 based. So the first one has the index 0. Then we need to have the minus 1 here because the count is not 0 based, it's made for you. And you count from 1. Also, if the animation has gone too far and it is not looped, which is the case here with the else statement, then we should probably stop the animation, right? So this object is started. We need to set that to false. And then I'll close up like that. Oh, actually I can't close up. I need to actually change the source field over in the image class. We need to update this rectangle to point to a new, to contain the values of a new rectangle. So this object's source needs to be changed to one of the frames, right? And you remember we used the straight brackets to access one of the frames. You see you have an index there that we should pass in. Well, we can't pass in current frame because, as you can see, this is an integer, and you remember that current frame was a float, so that we could keep track of parts of it, parts of a second, parts of an animation, because the elapsed game time might be very small. So we need to cast this one as an integer, and then we can use the current frame as the index of the frames. Okay. Let's save that, and then let's play with this new animation class in our engine. So I'll add another field here called animation. Let's do that as the computer, because the image looks a bit like a computer. And I'll collapse that and expand this instead. In the engine, just like the box, we need to add instantiate the computer as well. So we have a new animation. I'll collapse that and expand initialize. Here we also need to take this object has a computer which needs to be initialized as well. As you can see, we're starting to have many of these listed, and we have a box and we have a computer, and that's it. And can you imagine what it's going to be like when we have 15 enemies and tiles in the background to run on, and platforms moving around and so on? There's going to be a lot of these statements, and the engine is supposed to be an overview. So we're going to have to need to manage these somehow, and we're going to do that with a new class later on, a manager. But let's leave it like this for now. It's not fully needed yet. Now remember that I renamed these to be capital, so I need to change this to capitals as well. And same thing down here. Oh, sorry, that one instead. And textures and cursor. Now I'm gonna resort these a little bit. I'll take that one and move it down like that. And then we can copy this and paste it in. Move it up a bit. And instead of the box, we have the computer sheet, right? That was the name of the asset. And instead of box, we have computer. And that should make us happy. Okay, we're done initializing. Now we just need to update and draw it as well. So we have this computer needs to be updated when we pass in game time. And I can collapse that. In the draw method, we draw the box, right? Besides the box, we need to draw the computer as well. Pass in game time again. Pretty clear? I hope so. Let me show you just quickly how inheritance works in real code. Where can I show you this? Oh, maybe we can just do it here. This computer, you see we have several methods here. Well, if we go over to the animation class and we don't inherit from image, then when we go back to the engine, you'll see that we don't inherit as many. So inheritance simply just borrows some methods and fields from other classes. And if we go back to animation, here we override and we call the base class. And this was polymorphism because we are changing the method. We're changing the method in the image class to be something new, give it new behavior. And we have a lot of private fields, and then we have one property that is public, which means that over in the engine, I'll type that again. In this list, we have the property, but we don't have all the fields. This is called encapsulation, because you don't have to see all the things that you're not gonna use anyway. The image is the base class, and animation is the derived class. And what else did we have? Oh yeah, when we use polymorphism, we need to override the method in the base class, and to allow that we need to make the base method virtual. This refers to this object no matter if the source is part of the base class or if source is part of the derived class. We can still use the same, as in origin, for example. However, the word base always refers to the method or field in the base class. Okay, I'm gonna build this. See what I missed. Yeah, I missed something. Of course, there should be a semicolon there. I'll build again. Well, this time it succeeded. So I should be able to just click play or start. And then hopefully we get a computer that has a little screen. Yeah, it is updating. Scrolling along fine. We're happy with that. In video 25 we'll go over some vocabulary, and then after that in 26 and 27 we'll start using farsier physics. Bye for now.